Okay, we're going to be looking at right triangle trigonometry today. So we're going to be defining our trig functions in respect to this triangle as it's defined here. So if this is angle theta, this is considered opposite of angle theta, and sometimes in this case we'll denote it with a letter B. This is adjacent side, so it's A. And then this is our hypotenuse side, and that's probably the most important, is because the hypotenuse is always going to be that longest side. Sine of theta is defined to be the opposite over the hypotenuse. So if we were using these letters, it would be the B over C. Cosine of theta is adjacent over hypotenuse, A over C. Tangent is opposite over adjacent, which is your B over A. Cosecant theta is hypotenuse over opposite, which is C over B. Now we've been talking about relationships between these, and this is consistent because remember these have that reciprocal property. Well, this is opposite over hypotenuse, and this one is hypotenuse over opposite. And you can also see that B over C, C over B, A over C, C over A, B over A over B. So technically, if you can just remember the main three and know your reciprocal properties, then those aren't hard to know all 6 of them. So if you'll take a few minutes, pause this so you can have your definitions, then we'll move forward with a few examples. Also, real quick, this is really popular in remembering these definitions. So SOHCAHTOA says sine is opposite over hypotenuse. Sine of theta is opposite over hypotenuse. Co comes from cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So if this helps you, it seems to be something that's popular and some people like it, then you can use that to help you remember these, and then you just have to recall the reciprocal one to get the other 6, or the other 3, excuse me. Okay, so our first example is just say find the value of the 6 trig functions given side A is 24 and side B is 18. So I pulled up a sketch because the sketches are going to help us. This is a right triangle. Side A, if side A is 24, and we label side B to equal 18. Now, to be able to label all of our definitions, we need all sides of this triangle. How can we find this missing side? Pythagorean theorem. Yeah, so we should be very familiar with that. So we're going to pause it, do Pythagorean theorem to find our missing side there. Okay, so if you want to check your scratch work over here, we found our missing side to be C. Okay, the first one we're going to start with is we're going to calculate our sine of theta. Sine of theta is defined to be the opposite over the hypotenuse, so opposite over the hypotenuse would just be 18 over 30. Okay, so, and let's put our COH. Let's put that up there as a reminder. So sine is opposite over hypotenuse. Opposite over hypotenuse. What about 18 over 30 though? It reduces a little further, so let's go ahead and simplify that. Divide looks like a 6 out of each of them and just simplifies to 3/5. Okay, next let's do cosine theta. Okay, up here is just going to be adjacent over hypotenuse, so adjacent over hypotenuse, that would be 24 over 30. Simplify that, it reduces to 4/5. And let's move on to tangent of theta. Opposite over adjacent, so opposite is 18, adjacent would be 24, so 18 over 24. Now when we're doing these opposite over hypotenuse, it's always in respect to your angle theta, so sometimes angle theta might be in a different location, so make sure you're always working with angle theta. And that reduces to 3/4. Alright, We're going to come back up here. Let's do cosecant theta. Alright, which is just the reciprocal. We can either do that by our definition to be hypotenuse over opposite, so hypotenuse over opposite, or what else can we do? Right, we can do the reciprocal right there, so I'm just going to make a note. That's hypotenuse over opposite, which is just going to be 5/3. Then we have secant theta, which is just going to be the hypotenuse over adjacent. By definition, the hypotenuse 30, adjacent 24, simplifies, or reciprocal 5/4. Okay, and cotangent theta, adjacent over opposite. So adjacent would be 24, opposite would be 18. That's going to reduce to 4/3. And that's all 6 of them. Okay, let's move to our second example. This time, instead of giving us A and B in terms of just numbers, they gave it to us in a figure, and they labeled this triangle, but they gave me 2 sides and not a missing third side. So the first thing we need to do is use Pythagorean theorem to find the missing side, but this is either an A or a B, right? The only thing that has to be for sure is the longest side has to be the hypotenuse. So go ahead and set up your Pythagorean theorem and then check your work before we move forward. Okay, so I hope you found your missing side to be 6. Technically, it doesn't matter if I choose this side to be A or this side to be B or vice versa. The only thing I have to be very careful is that my hypotenuse is always the longest side. That's always going to be my C. And square, just a quick note, square of a square root just gives you 37, and then this simplifies to plus or minus 6, and of course we're working with the positive value. So we found our missing side. Now we just need to pull our definitions and go ahead and start with this. So sine of theta is just going to be opposite over hypotenuse. Okay, what did you get for that? Opposite. Now here's theta. This is what I was talking about. Opposite of theta is 1. And what's the hypotenuse? Square root of 37. Now that's fine for our trig definition, but algebraically, what about it? Yeah, it's not simplified, so we want to rationalize this denominator. So multiply by the square root of 37, and we've done this a few times now. So that would just give me the square root of 37 over 37. Okay. Cosine of theta is going to be your adjacent over your hypotenuse. Alright, so from theta, adjacent would be 6. Hypotenuse, once again, is square root of 37. And so what about this? Same thing. We need to take the algebra step to simplify. And this would give us 6 square root of 37 over 37. And let's do our tangent theta. Opposite over adjacent. Okay. Come back up here. Opposite is 1, adjacent is 6, so that one's worked out nicely. Put that back in blue. Okay. Cosecant theta. Alright. Now, here's the thing. I can use my cosecant theta is going to be my hypotenuse over opposite, right? It's the reciprocal of this. If I use this, the simplified version, what would I have to do? That would give me that over this, and then I'd have to do all that algebra step to simplify. If I'm going to use a reciprocal property, it's much easier to use this not simplified form, because now what would be the reciprocal of this guy? Just the square root of 37 over 1. So keep that in mind as if you prefer to use that. So using the definition, hypotenuse over opposite would just be square root of 37 over 1, square root of 37. So just a special note there. Secant theta is going to be hypotenuse over adjacent. So by definition, hypotenuse over adjacent. So that's just going to be the square root of 37. Put that in blue. Over 6. And then our last one's going to be our cotangent theta, which is adjacent over opposite. And let's come up here. So adjacent is 6. Opposite of theta is 1. So that would just be 6 over 1, which is 6. Now that one wouldn't have been bad, right? Reciprocal of this. But so keep that in mind if you use reciprocal properties.